It's time to move on and dive deeper into Go. In this course section, we are going to explore functions. We are going to explore this key Go feature and learn what exactly functions are and how we write custom functions. We are going to then see how we can configure and tweak functions to meet our requirements with help of parameters and return values. And we are going to dive into this special Go feature, which we don't have in a lot of other programming languages, where functions are not limited to returning a single value, but may actually return multiple values. Now, before we dive into any code, let's answer an important question first. What exactly is a function in programming and in Go specifically? I personally like to explain functions as code on demand. A function is a construct, not just in Go, but in all programming languages in the end, that allows us to define some code ahead of time. So code that should not be executed right away when it's parsed, but instead which should be saved to be executed later. And the code should then be executed once you call a function, which is simply the usage of a special syntax in your code. Once that happens, the function code executes. And then functions allow you to not just execute code at a certain point of time, and possibly also multiple times, but you also have rich configuration options, and you can but don't have to accept input with a concept called parameters, which we'll explore in this section, and you can but don't have to produce output, which we call return values. And we're going to explore all of that in this section, but that is, in theory, what a function is in programming and in Go specifically. Now, we already saw one function in action plenty of times in this course already, and that was the main function. And in general, in Go, you create a function by using the func keyword that tells Go that you want to create a function. Then you pick any name of your choice, though the main name is special. I'll come back to it in a second, but generally it's up to you. Then you have parentheses, and we can add something between those parentheses. We'll also do this in this course. And then you have opening and closing curly braces, and between those curly braces, you have the so-called function body. You have that code that should not execute immediately, but only once the function is called. Now, the main function is a special function, as I explained before. It's a function which you don't call yourself, but instead which will be executed by the Go engine, if you want to call it like this, once you run this Go program. And it's the main entry point of the program, so main is kind of a reserved and special word. But in this section, we're going to add more functions, and for those functions, the names will be up to you. Now, when it comes to calling a function and how that looks like, we might not be doing it for main, but we are doing it here in line 6 with println. A println is a function built into the format package, so provided by the format package, and we execute a function by referring to its name and then adding opening and closing parentheses after that name, potentially, as we have it here, with a value or even multiple values between those parentheses, which are then provided as input to that function. But again, that is something we'll explore in greater detail throughout this section. Now, that is a basic function, which we saw plenty of times before. In this section, we're now going to write our own functions, and we are going to learn about different ways of writing these functions and using these functions. So let's dive right in, and let's write a second function. Let's say here in the main function, we don't just want to output this dummy text, but the sum of two numbers. So we could have the numbers a and b. A is 5 maybe, and b is 10. And the concrete values here are hard coded into the code by me. So I'm just locking them into the code here. I'm just writing them as a developer. Of course, in a real program, we might be fetching them from the command line, from some user input, as we did it in the BMI calculator example in the previous section. I just want to save some time regarding that, and hence here I'll just use two dummy values. Now we might want to add them together, and of course for that we could add a sum variable and just add a plus b like that, and then work with that variable. But maybe adding two numbers together is such a common operation, which we perform so often in our code, that we want to define a short custom command, which is in the end what a function is, that we can then re-execute over and over again, and we don't have to write this code over and over again. Because of course, for demo purposes, this is a rather simple piece of code, and writing it over and over again wouldn't be too hard, but nonetheless, we might want to outsource it into a custom command, which we can just execute. Also, so that if we ever change this to a subtraction, we don't have to do that in 10 different places of our code if we had that code snippet in 10 different places. But instead, we only have to do it once in our custom function, and then all the places where we refer to that function will automatically use that updated code. So that could be another reason why we might want to outsource it. And hence here I'll add a second function, and we can add it in front of main or after main. It does not matter. Here I'll add it after main, and I'll name it add. Now I did mention that the function name is up to you, with the exception of the main function, and then the function name should describe what the function does. So in case of variables and constants, you typically want to describe what's stored in the variable or constant. In the case of functions, you instead want to describe what the function does. And if this function adds two numbers, add sounds like a fitting name. Then we add opening and closing parentheses and then curly braces. And now here we could move that code into that function and do that calculation in here. But now we'll face a couple of problems. For example, we have those red squiggly lines on A and B. And the reason for that is that A and B are variables in the main function and therefore only available in there. If you don't define variables as global variables, they by default are only available in the function in which you defined them. And hence A and B are not available in add. Now, of course, we could turn them into global variable so that we're able to use them in all functions, but it's generally not considered a good practice to make all your variables global. Instead, you want to narrow down the scope as much as possible. In addition, this function should also work standalone and not depend on any global variables, because if we would depend on such variables, it would mean that anything that changes those variables anywhere in the program potentially changes how that function behaves. And that's also something we typically want to avoid. And that's where function input, so-called parameters, come into play. Functions don't have to take parameters. For example, the main function receives no input, but they may take parameters. And we make it clear that a function should accept some input, so-called parameters, by adding them between those parentheses here right after the function name in the function definition. Here we can accept any amount of parameters we want to accept, and we can give them any names of our choice. For example, num1 for the first number and num2 for the second number. This then creates variables that are only available in that function, but variables that can be set when that function is called. Something we'll do in a second. A println does the same internally. It basically accepts the output text as a parameter, and when we call the function, we pass in the concrete value for that parameter that will then be used inside of that function. And here we're doing the same. We are defining that this function takes two parameters, which will be set once that function is called. Now num1 and num2 are now available like local variables inside of that function, but still we're getting some errors here. And the reason for that is that Go is still a language that's all about types, about value types. And just as we have to define types when we declare variables or provide an initial value from which the type can be inferred, as it's the case here, we also have to define the types for our parameters. Because here, Go at the moment has no chance of knowing which kind of value type will be used for num1 and num2, and that's not allowed. So to make it clear which types of values we'll get here, we should again add the type identifier after the parameter name, just as we added after the variable name if we use that longer variable definition syntax we saw earlier in the course. So here I know that, for example, I want to work with integers, and hence here I'll add int after num1 and num2. And now it's clear to Go that we'll get some integer values here. Of course, we could also accept floats if that makes more sense for us here, but I'll go with int. Now with that, we can calculate the sum, which is also of type int since we add two integers. And with that, add does its job. But we calculate the sum, and at the moment sum is a variable that's only available inside of add. As I explained before, a variable defined in a function is only available inside of that function. We could fix it by using global variables, but as mentioned, that's not recommended. You should avoid that. And therefore, instead, what we want to do to make that result available outside of this function as well, in the place where the function will be called, we typically return a value by adding a return statement, by adding this return keyword. Now, just like parameters, you don't have to add a return statement. The main function, for example, has neither parameters nor a return statement. And that's absolutely fine as well. You can have functions without both. You can have functions with parameters but without return statements. And you can have functions without parameters but with return statements. Here we have a function that will have both parameters and a return statement. And here I return sum. So I return the value stored in this variable. But again, I get an error with that. And the error I get here in the end is that this function, the add function, in the end doesn't expect any results, any returned values. Because in Go, you need to make it clear if a function will have a return value or not. And you don't just make that clear by simply throwing in a return statement. Instead, you have to add a little annotation after this parameter list here. Here, you have to define the type of value this function might return. So if this function returns an int, you should add int here. Just as you add the type after a parameter or a variable, here we add the type of value created by the function after the function definition, so after the function name and the parameter list. And now this is a valid function that makes it very clear that it wants two numbers, two integers as parameters, and that it will generate and return an integer. And hence we then have to return such an integer here. And of course, instead of writing this in 2 lines, we could also shorten this and just write 1 line and get rid of that second return statement here. Now we have that add helper function, and now back in main, we could re-add our sum, but now produce it by calling add and passing a and b to add, like that. And then instead of printing this dummy text, here we could output the sum. And that would now be a short first program that actually uses a custom function in addition to that main function to do its work. Of course, it's still a dummy function. As mentioned before, for this simple operation, we could argue whether we want it or not, but it's a great example for getting into functions and to understand how they generally work. And therefore now if we try to run this module, which I created here, I get 15 as an output here, which indeed is the result of adding 5 and 10 together. Now I mentioned it before. Functions can but don't have to take parameters, and they can but don't have to return values. And therefore, let's write a second function. And I want you to write this function on your own, simply to practice this a bit more. You should write a function with any name that makes sense to you that actually just prints a new line, and it should print the input that function receives. So that's your job. As a simplification, that function should only work with integer inputs, so no other types, since we don't know yet how we could accept different types. So only integer inputs should be supported, and then the function should take an input and print it to the command line. Try this on your own first. I'll give you a few seconds to pause the video and try it on your own, and then we'll implement this together. So, did you succeed? Let's now write such a function together. And again, it will of course be a rather simple function. Later, we'll also have more complex functions, but it's a great practice. Below the add function, though the position doesn't matter, I'll add the print number function. The name is up to you, but again, you should describe what that function does, and that function will in the end deal with outputting a number. So here, I'll then add my parentheses and the curly braces, and then I mentioned that this function should take an input, a parameter, therefore. And here I'll name it number, and I mentioned that we should only accept integers for now, so I'll make that of type int. And between the curly braces, we can now output that number. And for that, of course, I can just grab this line of code from line 11, println, cut it, and add it here, and then output number. Again, it's a rather useless function since it just wraps one line of code, you could say, but it is a good practice. The interesting thing about this function is that that's a function that takes a parameter but doesn't return anything, because it doesn't need to. It just prints something to the command line. And therefore we don't add any type after the function name and the parameter list, just as we didn't have anything after main. Now inside of name, we can now call print number, this function we just added, and then pass our integer number to it. And to make that function a little bit more useful, though that's of course optional and probably not something you did, we can of course switch from println to printf instead, and then format this in a more detailed way, so with richer formatting options, and for example say the number is, and then %v, and then output number like that. Now we added at least a little bit of extra utility to this custom function. And hence now with that, if I run this module again, I get the number is 15, output like that. So that is working, and that's now a second custom function in action, this time a function with parameters or with one parameter, but without a return value. So the basic idea and syntax behind functions should be clear. Let's now dive into a special feature of Go, which we don't have in all programming languages. In Go, functions can return multiple values. Now, with that, I don't mean that you can have return multiple times in the same function. If I return this, for example, that would not work because this return statement, the second one, is never reached. Because once you execute this return keyword, so to say, once this line of code is reached, the function execution stops and any code thereafter is not executed. So that's not how it works. But you can return multiple values by comma separating them in the line where you use the return keyword. Now for the add function, that doesn't make a lot of sense, but what about these numbers? What if we would want to generate some random numbers here? For that, we can add another function, generate random numbers, sounds like a good name. And that's a function that actually doesn't take any input, let's say, but it should return values, and it should return two values, two numbers. Now, first of all, we need to generate the random numbers. And for that, we can use another built-in package provided by Go, and that's the rand package. And here we got two packages called rand. We need the one from moth. So if we select this one from moth/rand and hit tab, this import gets added. And now that's still a package, even though there is a slash here. It's basically a package inside of another package, you could say. You can create such packages on your own if inside of a package subfolder you add another subfolder which contains then yet another package. And that's what's happening here. We have the moth package and that has the rand sub package. Now this is a package built into Go which gives us a lot of utility functions that deal with generating random numbers. We access them through a dot as before. And then here we got the int n function. And here we see a little explanation about this function. In the end, this is a function that takes one parameter. So it's a function built into Go that takes one parameter, as we can tell, of type int. And then it will produce a non-negative random number between 0, which is included, and n, which is excluded. So that number which we pass here is not an actual result we can get, but up to that number we can get any integer. And it will then return that random number which it generated. So here we call this function by adding the parentheses. And since we want a parameter value here, we pass it, and that should be a non-negative integer, and I'll just pass in 10 here to generate a random number between 0 and 10, 10 excluded. Now this returns an integer as we learned, and therefore I'll have my random number 1, which I store here, and then I repeat that to generate a second random number. So now I have two variables here inside of this function for two different random numbers. And of course, they could also be the same. They will be recalculated every time we call this function. And every time we do that, brand new random numbers will be generated. Now I want to return both numbers, and that's now the special thing about Go. We can add our return statement here, and where in many other programming languages you can only return one value here, in Go you can return random number 1 and then add a comma and also return random number 2. Now we just have to adjust our function definition here and make it clear that we will return two values which each are of type int. And we do that by adding another pair of parentheses here after the function name and the parameter list, which is empty, but which we still need to add. And there we now add the types of all our return values, int and int separated by a comma. If you only have one return value, you don't need the wrapping parentheses, then you would just add int like this. But if you have more than one return value, you need to wrap those return value types in parentheses and then list them as a comma-separated list inside of these parentheses. And now we have this generate random numbers function that produces more than one result. Now, of course, in other languages, like for example JavaScript, we also have workarounds, which still in the end allow us to return multiple values. For example, in JavaScript, we can return a single value, which is an array, which is a special value, which also exists in Go, which we'll explore later, which is one value that can then internally store more than one values. So with that, we return one value in the function, but that one value holds multiple values. And we can do something similar in Python. There, it even looks very similar to what we do in Go. This is a so-called tuple. It's also one value, just as the array in JavaScript, but it's one value with multiple values internally. So there are ways in other programming languages as well, but in Go, it's built in just like that. But with that, we got our generate random numbers function. And now we can call that here to produce these random numbers here in the main function. For that, we call the function as we learned it, by using its name and adding parentheses thereafter. And now generate random numbers returns two values. So we can of course create our a variable, but that's not enough if we just store it in a. Instead, now we get two return values. Hence, if we want to store them in variables, we also need to create two variables. And we can do that by simply adding a comma here on the left side of the colon equal sign operator, and then list all the variables we want to create here. It would also work, by the way, if we just use the equal sign operator for existing variables. We can then also reassign multiple values to multiple variables in one go. The syntax would be the same, just without the colon. But here we create brand new variables, and we create multiple new variables in one step for these different return values returned by generate random numbers. With that, if we now run this code, we'll get a different result. However, at the moment, we'll get the same result every time we run this, and that just has something to do with how this rand package and the random functions in there work. In order to produce different numbers every time we run this program, we would have to create a so-called source using a seed, and that's a little bit too advanced right now. I'll attach an article that dives a bit deeper into that if you're interested in it. For the moment, I'm fine with getting the same random numbers, which is not really random, but you get my point, because this section, of course, is all about writing and using custom functions, and that works quite well now also with multiple return values. Now, when working with return values, no matter if it's one or multiple return values, you can use a little shortcut in Go, which I only recommend for usage in simple short functions, since it can make your functions a bit harder to read if they get very complex. You can name your return values. And at the moment, we're not doing that. In both functions where we have return values, we just define the type here, and then we return values like this. And that's the default case, which I recommend for most functions. But for simple functions, we could also work with named return values. To do that, we have to wrap our return types into parentheses, even if it's just one. And now we can use any name of our choice for that return value. For example, sum. Now that creates a brand new variable, which is available inside of this function, which is declared right from the start, and which is initialized to the null value of that type. In case of an integer, sum is initialized to the number 0. And then here in the function, we could use that variable, which is now available, to store that result, for example. Now here I don't use colon equal sign, but just equal sign, because the variable already exists. As I just mentioned, it's created automatically by Go. So I just assign a new value to it, effectively overriding its null value, the 0 value, and then that's the new value stored in sum. And now we don't even have to return sum, though we can do that as well, but it is enough to just call return, and Go will then automatically return the variables defined here in that return list. So it will return sum here. Hence, if I save that all, and I now run this again, this still works just fine as it did before, but now with that slightly changed syntax using these named return values. And we can do the same if we have multiple return values. For example, here we could use R1 for the first random number and R2 for the second random number. And then here we just set new values to these variables. Hence we have to remove the colons because the variables already exist. And then just calling return is enough. And here this certainly saved us a bit of code. It's now shorter and maybe a bit more readable. So in short, simple functions, you might be able to simplify them by using named return values. In very long, complex functions, where you then maybe also introduce other variables throughout the function which will not be returned, it can quickly get confusing if you use named return variables and this return statement, which doesn't directly clarify what it returns. You then always have to have a look at this list to understand what's returned. So it's a trade-off, but it is a feature worth knowing since you will see it in other Go examples in the built-in Go packages and also from time to time throughout this course, like with these examples here. And that's it for functions. It is a rather straightforward feature, nonetheless a key feature which you'll use all the time to split your code into reusable code blocks, which you then can execute when you need to execute some code, potentially also multiple times. You can call every function more than once if you need to. And you learned about all these key features that make up functions. How you generally define them with the func keyword, that the name should describe what the function does, with exception of the main function, which is a special function, that you can but don't have to take input parameters, as many as you need, separated by commas, where you give them any names you want and define the value types they will be of, and that you can return values, but you don't have to do it. If you return values, you have to define the type right after the function name and parameter list. And you can optionally also use these named return values I introduced in the last lecture. You can also return multiple values in one function, in one and the same line. And you can then, of course, also store these multiple values in variables and then do with them whatever you need to do. These are functions, and now to practice them a bit more, we'll go back to the body mass calculator and see how we can improve our code there by using functions, more custom functions.